Hey folks, today's topic, we're continuing last topic, but we're adding the verification part of it. So this is really what our goal is. We're trying to take what we call an identity. It's a statement that's already true. For instance, 2 plus 2 equals 4. That's not an equation. 2 plus 2 equals 4 is a fact. We call those identities in mathematics. So this is an identity, a trigonometric identity, and we're trying to prove that it's true. So you're going to pick one side. You're going to use algebra until you can get to the other side. So you're going to take the side with more stuff on it, and you're going to manipulate it like we did yesterday. Remember where we changed things into sines or cosines or look for squares? And we're going to mess around with that until we get to sine. And then when we get to sine, we're all done. That's what our goal was. So I'm going to have my unit circle handy, especially the reciprocals and my Pythagorean identities, and a reminder that sine squared really means the whole term, the whole thing is getting squared. All right, let's go. Let's jump into it. So verify that cosecant of epsilon minus cosine of epsilon, cotangent of epsilon is equal to sine of epsilon. So I'm going to be picky. In my class, you must prove these, and you must prove them very in a particular way. I want you to pick a side that you're going to start with. You should rewrite that side exactly as it is. So whichever side you're going to pick, start with that side and rewrite it. Don't start messing around with it. Don't change anything. Just pick the side that you're going to start with. And you have to show each step here. Just turning this side into that side is not the goal. You're proving it. You're verifying it. So that means that when I read it, I'm able to see what you were thinking. So some kids are like, oh, I did that in my head. No, that's not how this works. I have to be able to see how you got there. So make sure that all your thoughts are clear on the paper. Now, which side do you pick? It doesn't matter. You could pick either side, but I recommend usually pick the side that has quote unquote more stuff on it, because that's usually the side that you can manipulate more. So I'm going to start with this side. So I'm going to rewrite that side exactly as it is. Cosecant of epsilon minus cosine of epsilon, cotangent of epsilon. So the first mistake is kids forget to pick a side and write it exactly as it is. Second mistake, kids forget to include a variable after each trig function. So if you want to just use x every time and be boring and not be a mathematical loser, no, just kidding. You could do that. If you want to be a little bit more daring and a mathlete and you want to use your Greek letters, I would recommend that. That's great too. But you must include something afterward. Now you can't start with epsilons and then change them to x and change them to y's and then change them to thetas at the end. So pick something and go with it. So if you don't want to write the Greek letters, rewrite this using x and then use x throughout the rest of it, or y, or whatever you want to use. All right. Let's see. I don't see any squareds, but I do see some stuff that's not sine or cosine. So I'm going to change those first. Cosecant's 1 over sine. This should feel familiar. This is what we did yesterday. Cosine is cosine. Cotangent is the reciprocal of tangent. So that's cosine on the top. Now notice how I wrote that cosine, the first cosine. I put it in a way that I knew I had fractions. So I usually like to write these so that you can tell that there's fractions involved. I also like to put the over 1 to help me remember that that's a fraction on the top. Now look, folks, once you've done one of those first two moves, the rest of this is just middle school algebra or arithmetic. The problem is telling you what you have to do next. You don't really have a choice. This fraction is connected to this one by subtract. This fraction is connected to this one by mul. What's stronger? You have to do multiply first. Okay, well, if I have to do multiply first, how do you multiply fractions? You multiply straight across. You do not need a common denominator. So I'm going to rewrite this. Notice I'm not ignoring that piece because I didn't change it this time. I'm rewriting everything. So cosine times cosine is cosine squared. Technically, that squared is around everything, but we agreed on this notation that putting the squared after the cosine really means it's around everything. Cosine times cosine is cosine squared. 1 times sine is sine. Equals. All right, now, at the end of the day, this is a fraction. At the end of the day, this is a fraction. And what are we trying to do to them? Subtract them. So if you're going to subtract fractions, you must have, hopefully you said, common denominator. So let's do a quick review. X over 5 plus y over 5 equals. Now, if you already have a common denominator, life is good. I usually write the denominator first, because when you have that, the common denominators don't add up. That's your denominator. That's what we're counting out of. This is a fifth. This is a fifth. So it's going to add up to something out of a fifth. Then if you have unlike terms, x plus y, that's not xy. I can't multiply. The xy means they multiply together. X plus y is simply x plus y. So sometimes I can get the denominator to be common, but I can't actually combine the top any better than just rewriting what I had before. And that's what I have here. I always start off with the new common denominator. Sine and sine have a common denominator of sine. And then 1 minus cosine squared is, I don't know, 1 minus cosine squared. I can't put those together. Now, whenever you run out of room, you leave an equal sign and then you start another equal sign down below. So that's just telling me that I'm continuing on the next line down. All right, does anything jump out to you here? It's like screaming at me. I've done a lot of these and it's like jumping off the page. 1 minus cosine squared is one of my Pythagorean identities. So I would look up these and I would try to find the one that says 1 minus cosine squared. And if you look, you'll see 1 minus cosine squared is the same as sine squared. So I can substitute that in. Divided by sine squared, my bad, divided by sine. If you have a sign on the top and a sign on the bottom, we can cancel one of them out. So I'm going to kill the squared and I'm going to kill the sign on the bottom. So I'm left with sine. How do I know I'm done? Because they told me that I was going to stop when I get to sine. And when I get to sine epsilon, I stop. Now, don't box anything in here. If you're going to box anything in, you'd have to box in this whole thing because your work is your proof. All right, not this. We already knew that the answer was going to end up at sine. I didn't need you to box that in. That's not the solution. So how do we end a trig proof? How do we show that we're done? There's two ways. The first way, my favorite way, is to write the letters Q, E, D at the end. That is Latin quod, I think, erat demonstrandum. That's Latin for that which was to be shown. In other words, they told me that I had to show that this side could equal that side. I showed that, and so at the end, this is me talking trash, saying, hey, I just showed you what you told me that I had to show. That which was to be shown. I'll show you how to end the other one, another way to end it if you don't want to use QED. Okay, so here we go. Pick a side. Step 1, pick a side. That's going to be an annoying half point off of 3 points if you don't pick a side and start with it. Now, in this case, it feels kind of like there's 2 things here and 2 things here. But when we talk about terms, things that are connected by multiply are actually one term. So this is one term where these are separated by a plus or a minus. Those are 2 terms. So I'm going to start with the side that has more stuff. So that's secant squared beta plus cosecant squared beta equals. Notice I didn't change anything. I picked a side and I'm going with it. Now, sometimes you pick the wrong side and you got to get out your eraser and go back and start over. Sorry about that. That's the way it goes. All right, let's see how far we can get with this side. So I see squares, but I also see that these are not cosines and sines. So I'm going to go with, you could go either direction here. Usually you don't want to make that trade because secant squared is tangent squared plus 1. Cosecant squared is 1 plus. So you could actually, I don't know how that would, I'd have to go back and think about that. But that's usually a bad trade. See how I'm trying to get one term at the end? So if I trade secant squared for tangent plus 1, then I've got two things. I don't want two things. I'm trying to get down to one thing. So I'm going to go the other route. I'm going to turn everything into sines and cosines. So secant squared is the same as 1 over cosine squared. Cosecant squared is the same as 1 over sine squared. Okay. Oh boy, I don't have much to do from a trig point of view, but from my arithmetic point of view, it's pretty obvious what's coming next. It's telling me what's happening. I don't have a choice. I mean, what is this at the end of a day? It's a fraction. What is this? A fraction. What are we trying to do? Add them. So what does it take to add two fractions? Of course, you must have a common denominator. So just a quick reminder from your probably 5th grade days, 6th grade days, to get a common denominator, a guaranteed way to get a common denominator is to multiply the denominators by each other. So I'm going to multiply this by sine squared beta over sine squared beta. And I'm going to times this by cosine squared beta over cosine squared beta. So let's see now what our fractions look like. So this is going to have a sine squared beta on the top over what's sine squared times cosine squared? Well, sine squared beta cosine squared beta plus cosine squared times 1 is cosine squared beta. Sine squared beta times cosine squared beta is sine squared cosine squared. Actually, my math voice is really happy right now because at the end of the day, this is a fraction and this is a fraction and they have a common denominator. So I start my next level by putting the common denominator out there first. Sine squared beta, cosine squared beta. All right, can you add together sine squared and cosine squared? No, those are unlike terms, so the best I can do is just put them together in the numerator. Equals, I ran out of room, so now equals. Okay, looking at this. All right, so it's tempting to see if things cancel here. A lot of kids want to cancel. So let's go up to the, in the margin here, and I want to leave a little reminder on how reducing things works. Let's say that you have x plus y over x times y. Does anything cancel here? Because that's kind of what we have, right? We have sine plus cosine over sine cosine. Does anything cancel here? No. It's tempting to cancel things, but if I circle, if I go and circle this section, and then I go and circle this section, all right? If I take the x over the xy and then the y over the xy, do any one of those share things in common? No. So these two share a y, these two share an x, but all of them don't share something in common. This cannot reduce. Another thing you might see is this, x plus y over x. Does this reduce? No, this does not reduce. Is there anything in common with x over x and at the same time with y over y? Do these three things have anything in common? Not all three of them. Not all three of them. And since it's not all three of them, this cannot reduce. If you want to reduce something, it has to belong to all three pieces. You have to have one thing in common. These have a y in common. These have an x in common, but they don't all share, they don't all share something in common. So we have to see something else. And to me, like I said, I've been doing this for a long time. This is, to me, the most obvious Pythagorean identity out there. It just screams to me when I see it on the page. Sine squared plus cosine squared. If you look up your Pythagorean identities, find the one that says sine squared plus cosine squared. That ends up being 1. Now, I don't have a Pythagorean identity for the bottom, so I'm going to have to rewrite that as is. Out of all the Pythagorean identities, that would be the one I want you to recognize the most. Actually, I think it's worth memorizing, especially AP kids. Okay, so are we done? No, we're still trying to get, always keep in mind where you want to end up. I want to end up with a secant squared and a cosecant squared. Well, what is, at the end of the day, what is secant squared? It's 1 over cosine. Do we have 1 over cosine? Yeah. What's cosecant squared? 1 over sine. Do we have 1 over sine? Yeah. Now, technically, I have the sine first, but multiplication is commutative, so I could flip these around. So 1 over cosine is going to make my secant squared beta. Then the 1 over sine is going to make my cosecant squared beta. Notice I didn't box that in because I knew I was going to end up there. So the other option, I'm going to use QEDs most of the time, but the other option is to draw a little rectangle like this. That's kind of like a period. It means that my proof is over. It has 2 names. It's called an Helmholtz, or the one I like better, it's also called a tombstone. The tombstone. It's the end of the proof. Let's do one more together, and then I'm going to encourage you to try a couple on your own. So let's look at the next one here. All right, so I've got, first off, before I even try to solve anything, I'm going to pick a side, and I'm going to use that side to solve. I like to pick the side that has more stuff. This clearly has more stuff, so that's the side I'm going to rewrite. So tangent of delta, sine squared of delta, minus tangent of delta over cotangent of delta equals. All right, there are lots and lots of moves that you could do. It all depends on how you attack it. What I see first is a move that most kids forget about. What does this term have, and what does this term have? They both have a tangent. And when you have a tangent in common, you can factor out that tangent of delta. Now, when I take out a tangent of delta, that leaves behind a sine squared of delta minus 1. So factor out. It's going to make your life a lot easier. All right, now I see a bunch of things here. I see this is not a sine or a cosine. This is not a sine or a cosine. And then this, to me, is a Pythagorean identity. I might have to go look up. So let's start with these two. Tangent is sine over cosine. So this is going to become sine of delta over cosine of delta times sine squared minus 1 is backwards. If I look it up, it's supposed to be 1 minus sine squared. So all that does is mean it's going to be the opposite of what it normally is. So this is going to be the opposite of cosine squared delta over, and then cotangent is the reciprocal of tangent. So sine over cosine becomes cosine over sine. From here, I'm going to put these two together. Multiplication of, this should be a fraction. Once I put them together, though, I'm going to still have to divide by this. So let's go ahead and flip and multiply right now. So when I flip and multiply, the sine is going to be on the top over the cosine on the bottom. And you should notice a lot of stuff cancels here. So how many cosines do you have on the top? 2. How many cosines do we have on the bottom? 2. So those are going to cancel out. And I'm going to get a sine times a negative times a sine, which ends up being negative sine squared delta, which is exactly where we're supposed to end up. QED. So it's like a puzzle. You're just, and the rules of the puzzle, the moves that you're allowed to do come from our Pythagorean identities and the relationship between the trig functions and the reciprocal trig functions. Okay, this is the first one I want you to try on your own. So pause, hit the pause button, and try to do example 4. All right, let's see how you did. So I want to come up with the side that I'm going to work with first, and that's clearly this side. I have more stuff over here. I'm going to use that side. So that's tangent of phi plus cotangent of phi over cosecant of phi. I don't see any squared, so I'm stuck with turn things into sines and cosines. So tangent is sine over cosine plus cotangent is cosine over sine over cosecant is 1 over sine. Step back at the end of the day, this is a fraction. This is a fraction. To add fractions, you must have common denoms. So I'm going to multiply this. Okay, so a guaranteed way is to times them by each other. So I'm going to times this by sine over sine. I'm going to times this by cosine over cosine. Notice I'm not forgetting the variables. Equals. Okay, so this is the division bar for the whole fraction. So I still have my 1 minus sine phi on the bottom. Then I'm going to do another division bar for my common denominator. So sine times cosine, sine. So sine cosine is my common denominator, sine cosine. And then my numerator, sine times sine is sine squared. Plus cosine times cosine is cosine squared. All right, is it jumping off the page to you? Is it screaming? It's screaming at me mathematically. It's blinking. I can see sine squared plus cosine squared is 1. So I have 1 over sine phi cosine phi over 1 over sine of phi. At the end of the day, this is a fraction divided by a fraction, which nobody can do. So instead we flip and multiply. Flip and multiply. Okay, so the sign on the top is going to cancel with the sign on the bottom. So the signs are going to be gone. And I'm left with 1 over cosine. But what is 1 over cosine? 1 over cosine is secant. QED. So the last one, I don't love these ones. I mean, it's such a big idea in advanced math that I hate to skip it. So I'm not gonna. But it's one of those that I don't think anybody would know how to do without somebody telling them how to do it. So we're looking at the situation where you got 1 plus sine over cosine and then cosine over 1 minus sine. It doesn't look like one side is any better than the other, and I would agree with that. One side is not any better. So just pick a side and let's start working with that side. So I'm going to pick the left side. 1 plus sine of lambda over cosine of lambda. Now, I can't turn anything into sines or cosines because they're already there. I don't have any squareds, so it's already there. There is one thing that's kind of jumping out to me. I see that I have 1 minus sine, but that's not 1 minus sine squared. So what I'm going to do is a move called conjugates that's going to generate that 1 minus sine squared that we're talking about. Let me show you what I mean. A plus b times a minus b. Watch what happens when I distribute this. A times a is a squared. A times negative b is minus ab. B times a is positive ab. B times negative b is negative b squared. Combine like terms. A squared minus ab plus ab cancels out, and I get then a minus b squared at the end. These are called conjugates. What colors am I using? I'm using those two, so then I can write that in this color. These are called conjugates. And conjugates allow you to square things without using squared. See how at the end of this, a plus b, the a ended up getting squared and the b ended up getting squared, but we didn't square anything. Conjugates allow you to square things without squares. I can't just magically change these into squares. But what I can do is multiply by the conjugate. And the conjugate is exactly the same except for the sign in the middle. So 1 plus sine becomes 1 minus sine lambda. Whatever you do to the top, you've got to do to the bottom. Okay, so now let's start to clean this up. What's 1 times 1? 1. What's 1 times negative sine? Negative sine. What's sine times 1? Positive sine, so that adds up to 0. And then a positive times a negative is a negative. Sine times sine is sine squared. So look at, what did we just generate? This is one of our Pythagorean identities. So multiplying by the conjugate allowed us to create one of our identities. So I'm going to actually write that up here. Multiply by the conjugate. And I recognize that I have to do that move anytime I have something that almost looks like a Pythagorean identity. Now, the denominator is not going to be as nice, and I'm not going to distribute it either, and you're going to see why in a minute. Remember, every one of these are set up to be true. You just have to figure out the path to get there. Okay, 1 minus sine squared, I look it up on my unit circle. 1 minus sine squared is the same as cosine squared. All right, what do you notice? Do you see why I didn't want to distribute that cosine? I mean, I could have, and it still would have canceled, but now I've got one cosine on the top. I've got two cosines on the top. I've got one cosine on the bottom, so I can cancel those out. That leaves me with the cosine in the numerator and a 1 minus sine lambda in the denominator. QED. That's exactly the same as where we were supposed to end up. So look, sometimes in notes, you can, pay attention, do really good paying attention during notes. And then, with the partner quizzes, you can kind of see it, talk to your friends. You don't really have to do the homework, or you do like some of the homework, you get the idea and call it good. No, this is not one of those scenarios. This is one of those where I really recommend digging in, trying to do every single problem on the homework, because every single problem is going to feel a little bit different than the other ones. All right, good luck.